Hi everyone, this is Scott Schmidt from the Operator Training and Certification Program. Today I'm going to be going over and demonstrating on the distribution practice exam the math problems. And just as a quick note, the calculator that I recommend is a TI 30X2S, and we do allow these on the certification exams. The reason I recommend this is a two-line calculator. You can see what you typed in along with your answer here. Okay, without further ado, let's go ahead and get this started. This is available on our website on the same exact location as the exam applications. If you scroll down on our webpage, once you get there, you will see a button that says practice exams. You click it and it will take you to that page directly where these are located. There are answer keys with the answers written out in Word format and how to do the math, but we decided to make educational videos with walkthroughs so that people would have an understanding how this is done. Okay, so on page 1 of this exam, you can see there's no math on it. And here we go, we run into our first math question on page 2. Okay, so here we have number 7. A water supply has a chlorine dose of 4.2 million gallons or milligrams per liter and carries an average residual of 0.9 milligrams per liter, and the demand is, okay, so there is a formula that says total dose equals residual plus the demand. So here I know my chlorine dose is 4.2, and I know that my residual is 0.9, and I do not know my demand. So in order to solve for it, you just do some simple algebra. Subtract from this side, that cancels that out. 0.9 here. So when I do that in my calculator, I'm going to go ahead and get it. And so 4.2 minus 0.9. And that's going to give me 3.3 milligrams per liter. All right, there's another math question right below this. 150,000 gallon water storage tank must be disinfected. If the final dosage of chlorine is 10 parts per million, how many pounds is HTH? This is a common name for calcium hypochlorite. 60% available chlorine will you use? So I'm going to go ahead and put my 10 parts per million into my parts per million equation. And then you have pounds of Cl2 over my million pounds of water. So I need to get gallons to pounds. In order to do that, I'm going to go ahead and convert it. So 150,000 gallons over 1. Well, on our math formula sheet, 1 gallon is equal to 8.34 pounds. So if gallons are up top, they must be on the bottom to cancel, which would mean 1 gallon goes here, 8.34 pounds goes here. And then we're going to go ahead and just multiply those, everything across top and then the bottom. Gallons unit cancels. So we're going to get 150,000 times the 8.34 is going to give me 1,251,000 pounds. Well, I need to get it to this big M unit. In order to do that, you just divide your pounds by 1 million. And this is going to give me 1.251. I go to 3 decimal points on this. So 1.251. Once we're here, there's a simple thing that we do is called cross multiply and divide. So in order to solve for this, we're going to just cross multiply these two, which is 10 times the 1.251, and this will give us our pounds of pure here. So 10 times 1.251 is going to give me 12.51 pounds of pure chlorine. Well, in order to get from pure chlorine to HTH, you just take the 12.51, you convert your percent to a decimal, so 1, 2 to the left, give you 0.6. So this gives you 0.6 for the thing, and now you divide this by 0.6, and we need 20.85 pounds of HTH, okay? One thing to keep in mind, because sometimes in treatment, we deal with given, say 10 pounds of HTH and what's your parts per million. A little rule of thumb that I like to use, or a trick, is if you're given the parts per million, you're going to divide by the percent, or then maybe the gallons too. So if you're given ppm, you divide, and if you're given a compound, you multiply by the percent. Okay, that's something that helps with determining, do I divide by or multiply by the percent? Here on number 13 is another math question. A water standpipe has a diameter of 18 feet and a height of 130 feet. If it is full of water, what is the pressure at the bottom of the standpipe? So pressure is PSI. 1 PSI stands for 2.31 feet of head. So that means every PSI you have 2.31 feet of water above a certain point. Well, nowhere in here does this say anything about needing the diameter, does it? The diameter in this is a useless stuff because we're looking for the height of water. So we have 130 feet of water. Well, it's over 1. And feet are up top. Where do they got to be to cancel? Well, on the bottom, so 2.31 feet and 1 PSI. Because if you think about something like this is your standpipe. PSI is measured pounds per square inch, which is just a nice tiny water column. So the diameter is not necessary for this. So multiply this way and then this way. And we're going to get 130 over 2.31. You divide those. And you're going to get 56.28 PSI. So this is a static pressure hydraulics type question, all right? So here in question 15, this doesn't appear to be a math question, but it actually is. So here on question 15, this doesn't be a math, here on question 15, this does not appear to be a math question, but it actually is. So it says, if the water is flowing at a constant rate of Q and the diameter of the pipe is doubled, the velocity will what? Blank. All right, so in order to do this, we need the QVA question, which I use a triangle for QVA because it helps it out. I call it the continuity triangle. And I put Q, V, and A. Q always has to be up top. Doesn't matter where V and A are. Well, to note just for this is always square feet. This is always cubic feet per second. And velocity is always feet per second, okay? So we're going to assume the flow rate is 1. It doesn't change. I like to use this, and I like to call it the rule of 1. So we need to figure out what the area would be as if the diameter was, let's say, 1 foot. So the area for a continuity equation is always the 0.785 of a square times the diameter times the diameter. We're assuming they're 1 foot. So this gives me an area of 0.785. So I put my 0.785 in here. And when they're top and bottom, you're going to divide. And when they're across from each other, you multiply, okay? So let's go ahead and divide the 1 for our flow rate by the 0.785 area and determine what we get for flow rate. Well, I got our velocity of 1.27 feet per second. So now it says, what would happen to the pipe if we double the diameter? So I'm going to have to make a whole nother Q or another triangle here. The flow rate's going to stay the same, okay? We're not changing that. So the flow rate stays as 1, but our area is going to change. So our area, we're going to double the diameter. Times by 2 times by 2, because it's now 2 foot by doubling the diameter. And this gives me a flow rate or area of 3.14 square feet. Now we divide those. 1 divided by 3.14 gives us 0.32. So the velocity went from 1.27 when we doubled the diameter to 0.32. So it is a decrease to a quarter of its original value. It doesn't increase at all, right? And it definitely doesn't remain the same. So the next one I want to do here is 2.26 million gallons per day is equal to blank gallons per minute. Well, the very first thing we need to do is get rid of this big M. In order to do that, you're going to go ahead and multiply this by 1 million. When we do that, it gives me 2,260,000 gallons over 1 day. So now I got to get days to minutes. And if days are on the bottom of a unit, they have to be on the top to convert them. So 1 day over 24 hours. The only two things that'll ever be here is what are equal to each other. So if I have hours on bottom, that means hours have to be on top. Cancel over 60 minutes. So I'm going to get 2,260,000 gallons over 1440. And that would be minutes for my units left because that's all it's left. And when I convert these, or I have to divide these now, I get 1,500 69 gallons per minute. Now, the next one's kind of the opposite of this. It says if a pump has a rate of 900 gallons per minute, what is the equivalent pumping rate in million gallons per day? So you go ahead and write what you start with, 900 gallons, 1 minute. Well, I need to get minutes to days, so you're going to do the reverse. The minutes are on the bottom. Minutes have to be on the top to cancel over 1 hour, so that cancels that. Well, my hours on the bottom, they have to be up top to cancel over 1 day. So when I do this, I'm going to get 1,296,000 gallons per day. But how do I get it to that MGD? Well, in order to convert things to MGD, just like on the previous page on the chlorine, you just divide it by a million and you're going to get 1.296 MGD, or as we can say, 1.3 MGD. So that's up to that page. And then here we got on number 21 and number 22. How many gallons of water are in 1 foot of 9-inch pipe? Well, the volume formula is 0.785 times diameter times times the height. Well, in this case, it'd be length, which is 1 foot. Well, you need to get this to cubic foot because I know that 1 cubic foot equals 7.48 gallons. So what we're going to do is we're going to go ahead and convert this 9 inches. So you go 9 divided by 12 equals 0.75 feet. Now, it's going to be volume equals 0.785 times 0.75 times 0.75 times the length of 1 foot. And this will get us cubic feet. So I got 0.44 cubic feet. That's over 1. Cubic feet's on the top. It's got to be on the bottom to cancel with 7.48 gallons here. So 0.44 times 7.48 gives us 3.3 gallons. You desire to flush 500 feet of a new 10-inch water main with a velocity of 2.5 feet per second. What flow of water in gallons per minute would be required to do this to reach this velocity? This keyword right here, velocity, tells me that this is a QVA. So I'm going to go ahead and set up my triangle for this. I don't know my Q. So in order to solve for a QVA, you're going to need 2 of the 3 things. Well, I know my velocity area. This is 2.5. So that just goes there. And now I need to solve for my area. Well, the area, if you think about it, it's talking 10-inch water main. So the area is going to be a circle. Okay. So with the area formula, you need 0.785 times diameter. With the QVA, your velocity always has to be feet per second, and your area always has to be square feet. So the very first thing to do is go ahead and convert our inches to feet. So this is going to be 0.83. So my area is going to be 0.785 times 0.83 times 0.83, and that's going to give me 0.54 square feet. And that's going to go here. When they're across from each other, like I said, you multiply those. So 2.5 times 0.54 is going to give us a 1.35. And this will be cubic feet per second. When you solve for Q, Q is always in cubic feet per second. So I need to go over here and convert this 1.35 cubic feet per 1 second. Well, just like before on the previous one, cubic feet are on top. They got to be on the bottom to cancel. And I know that there is 60 seconds and 1 minute. 60 seconds got to be on top, since seconds over here is on the bottom to cancel. Multiply that through, so I get 605.88 gallons per minute. 605.88 gallons per minute, or as you can see here, 606. Okay. So on to page 6. And we have one more math question here. A tank has a diameter of 35 feet and a depth of 18 feet. What is the volume of the tank in cubic feet? Well, this right here, diameter, tells me that we are dealing with a we're dealing with a cylinder. So volume formula for a cylinder is 0.785 times the diameter times the diameter times the height. Well, in this case, depth, same difference. 0.785 times 35 times 35 times 18 gives me 17,309.25 cubic feet, which would give me A. So thank you for joining me today in this video, and I hope that you find it helpful. You can find it along with the other treatment exam videos and going over the practice exams on the practice exam button. Thank you and have a good day, and I wish you all a good time.